Real quick, I did get an email and somebody asked, hey, where are the quizzes? Well, I haven't opened them up yet because you haven't learned anything yet. But they'll be at the very bottom of each section. It'll be the last thing at the section. It'll say section exercise. And when are the first 6 quizzes due? By the midterm, okay? So after today, after I lecture today, what I'll do is I'll go back to my office, I'll look at the quiz, make sure I covered everything, and if so, I'll turn it on, and then you all can take it. But I'm not going to turn the quizzes on until I've lectured. Okay. So I'm sorry you're not going to be able to magically do quizzes for fun. Skip ahead. All right. And I'm also going to go back up to my office and do the video, and it'll look like this, only it'll have the right date on it. Okay? All right. So that's Moodle. Let's actually lecture for a little bit. All right. So you're not actually going to do any math for a couple weeks. I have to get some of the science stuff down first. And what I want to talk about today is this. Answer the question, why statistics? Right? I spend too much of my time as a political scientist involved with statistics. And let's be honest, nobody really likes math. All right, I'm a statistician. I don't really like to do math. Like, I like sitting on my couch and watching TV. I like to do that. I don't like to do math. I don't get enjoyment from it. Nobody does. At least no normal person does. So why is math and specifically statistics so scary? Well, again, last class we talked about this. It shouldn't be. Because what we can actually get from it is actually quite helpful. Not just in this whole occupation of science and learning and academics, but even in our daily lives. And so that's what I'm going to try to show you today, is why this is going to be beneficial to you and why we do this. But let's first start about what's the difference between statistics and math? Well, statistics is more complicated than simple math. Statistics itself is a discipline. Right? I called myself earlier a statistician, as if that name has meaning to you. Right? Hopefully occupations have names to them. I'm the stuff guy. Well, what do? I do the stuff and the things with the whatchamacallits. That's not very descriptive, right? Nobody goes into college and they say, well, I want to be the stuff guy. Right? So a statistician. Casey, you got to take a notebook out. You're freaking me out, man. You can doodle in it, but you at least got to have it on your desk. All right. Stats, the science of collecting. I do a lot of collecting data. Allie is helping me out collect some data. Lots of data, right, Allie? More than any person needs. It's one of the things about statisticians. They love collecting data. Not as much as sitting on the couch. But if you're going to be doing stuff, data is good. Collecting data, organizing it. I'm really bad at organizing data. I have it everywhere. Right, Allie? Yeah, I'm really bad at that. Lots of files on lots of drives all over the place. I need to get better at that. Summarizing and analyzing data. That's when I write a paper, whether it's a conference paper that eventually hopefully becomes a journal article. Why do I do all that? To answer questions and draw conclusions. That's what statistics is. It's math with a purpose. It answers that question, why am I doing this? Right? Flashback to high school, and you're in a geology, not geology. You're in a geometry class, and you're talking about, why do I need to know the area of a triangle? I'll never use this. Right? I know how to balance a checkbook, not that you know what a checkbook is, right? But you know how to do this. Why am I ever going to need to calculate the slope of a circle? Do circles even have slopes? I don't know. I was bad at math. All right. Our math has purpose and why we're doing it. All right. The textbook, Howard T. Stats is a branch of math. Yes, that's true. Dealing with the collection, analysis, interpretation, and presentation of numerical data. So we got about the same, we agree, same definition of what statistics is. Right? How is it different than math? It's math with a purpose. There are people out there in math that are just trying to calculate pi, that whole deal with the circumference of a circle. Remember that? The magic number pi. There are mathematicians who are just trying to find out if it has an end. .14159. When I was a graduate student, a mathematician at Michigan State calculated it out to the billionth. Like, it's actually like the thing that they try to do. Like, I'm going to outlift you by finding the more and more digits of pi. Not sure what purpose that serves. Maybe just to know if it ever ends. Or if they can find a repeating pattern so they get to put that little line over it and be like, ah, I found it. The bottom. That's not what we're doing. Why does this work for you? Well, hopefully, outside of the classroom, you'll just start to make better decisions. One of the consequences of doing statistics is you notice when people are making horrible, horrible mistakes. And you try to convince them otherwise. But it doesn't usually work. Anybody here have family members, or you don't have to admit it yourself, that plays the lottery? How do we raise our hands in this class? There you go. You lock the elbow. Okay. They play the lottery, right? Do they ever win? Rarely. One of my co-authors does the scratchers, and he'll call me when he wins. Like, ha, won $100 today. It's like, dude, you and I have the same methods training. You know this is completely random, right? My mom plays the lottery. And it drives me crazy, because in New York, where I'm from, New York has this thing called Quick Draw, where it's a lottery every 5 minutes. And you can just sit down, you have your card, you do your numbers, which is a thing, and then you just sit and you watch to see if your numbers come up. And my mom has like patterns, so she's like that person that like picks numbers based upon birthdays and significant dates. You all are nodding your head, you're like, yeah, I know this, right? 27. 27 is my birthday. I was born on April 27th. So when you play 27, you also got to play 4. But mom says, my birthday's not good because 4 and 27 don't pair that often. Now, the thing about the lottery is it's completely random. Every draw is a random draw. Mom's never taken probability theory. Right? Mom doesn't understand that taking the number out has no influence on the next number that's picked. If I would expect there to be a relationship between 4 and 27, like they should be connected by a string. You pull out 4 and you're pulling on the string, and guess what's going to come next? 27. But mom doesn't have statistics training. She doesn't have probability theory. She just notices patterns. So you know what I did one day? I said, Mom, I love you, but you're wrong. And I'm going to show you how you're wrong. And then please stop wasting money on this. Or just admit that it's all random and, you know, we can play that game where you hand me money and then I randomly tell you if you won or not. That's a fun game for me. Hand me $5 and I'll say, oh, you won. Or just basically tell you you lost every time. So I pulled up the data for Quick Draw in New York State and the frequency in which numbers are pulled. They published this data, pulled it up on the computer in our living room, said, Mom, look at this. And it showed the frequency in which the number 1 has been pulled and the number 2 has been pulled, and on and on and on. And guess what? Every number has been pulled equally. So you can't tell me that 28 never gets drawn. You should not pick 28. Because 28 gets pulled just as much as 44, which is one of her favorite numbers. So I have evidence in front of her. Mom, 28 and 44 have the same frequency of being drawn. Do you think she still plays Quick Draw? Yep, all the time. I failed. Right? I tried to provide her with the evidence that would change her behavior. And actually, lots of people do this all the time without you really noticing or even caring sometimes if you're being influenced. The media does it a lot. This actually came out in the last couple of days, this headline. And I loved the headline because it was like so certain and just basically said, no, you just shouldn't do this, right? No amount of alcohol is good for your health. Not a drink a day, not like a drink every other day, not a couple of drinks when you're really stressed out. Like the certainty in this headline is just inspiring to me. Should I have a drink? No amount of alcohol is good for your health. Global study says. Do people still drink? Is drinking good for your health? Not according to that headline, or at least that study. But there are other studies that are out there, right? Study shows how red wine compound slows aging. I don't like doctors, like the medical doctors, because I don't think they really know what they're saying. And I had a doctor that told me I should drink more. And I'm like, no, I'm sorry. I'm done with you. I don't like red wine, and I don't want to drink every day. I think that's a bad thing. It's called a habit. I don't want a drinking habit. All right? Should I drink? Well, it's a question lots of people have every day. And is our behavior altered by knowing whether or not we should do something? Why is alcohol somewhat okay to drink? Give me a good reason why you should drink alcohol, even though it has no benefits at all to your health. Okay, makes me feel better. Okay. Okay, I don't drink because I want to drink. I drink because other people are drinking. Makes perfect sense to me. It does. It makes perfect sense to me. Because the only time I drink is when other people are drinking. That's it. Okay. Somebody give me an outrageous reason to drink. Like, you've been caught drinking, mom and dad are disappointed in you, and what are you going to say? Well, mom and dad, at least I'm... No. I can't talk now, I'm drunk. No. You ever try to do this? You ever try to say, well, I know this is bad, but it could be worse, right? I know I'm just drinking. It's not like I'm hooked on crack or heroin, right? So what's the benefit of alcohol? It's not as addictive as other things, right? There you go. That's why I should drink alcohol, because it's not as addictive as heroin. How do you know that? How do we know that heroin is addictive? Okay. What do studies use to tell us the level of addiction? Statistics. Okay. As much as I like to talk about what we know, I just have to always reinforce it with, we're not making this up. So Mom, I'm not making up that 44 and 28 are equally effective power balls. Even though they are. Statistically, they're equally effective. They have equal chances of being randomly drawn. Just like every other number between 1 and whatever it goes to. Because the data tell me that. Right? So generally speaking, you as individuals, again, sometimes without even knowing it, use statistics to make decisions. Anybody here buy a car recently? Cody. Cody with a K. Or Cody K. What kind of car did you buy? A pickup truck. Why? Okay, you got to carry stuff. What kind of car did you buy? What? A tiny clown car. Why did you buy the tiny clown car? Allie. Okay, who else? You got a Ford Escape. Why'd you buy the Ford Escape? All right, so everybody apparently buys cars based upon how much space they need or not need. Is that it? No? What do you guys buy cars based on? Thank you. All right? Speed. Shh. All right? Gas mileage. Why gas mileage? You got a 30-minute... Because when you buy a car, you expect to drive the car, right? Usually over some distance. Allie, do you drive a lot? Do you drive to class, for example? No, you walk, right? Which is why she has a clown car, because she's not going to be in it that much, right? You're going to commute. You're going to drive a lot. You buy a car with good gas mileage, because gas is expensive. How do we know what kind of gas mileage a car gets? Okay. What is the statistic for gas mileage? It has a name. MPG, right? Miles per gallon. That's a statistic. It's an average. It's a mean. The mean number of miles divided by the number of gallons you drive. MPG, right? So we make decisions based upon statistics, sometimes knowing that that's what we're doing and sometimes not knowing. Like, you didn't know for certain that heroin was more addictive than alcohol. Kind of had an idea. The other reason to use statistics is, this is a big statement, just to generally understand the world. Understand how things operate and how things function. How do we actually know what is true? And this is a hard one these days, because politics and the internet have essentially killed this idea of knowing what is true. So a couple hundred years ago, how did you know if something was true? Chances are you read it in a book, or a teacher taught it to you. Today, how do you know if anything is true? Because we have people on TV saying truth isn't truth. Just think about that one for a second. Maybe have a glass of wine, light a candle. Truth isn't truth. Okay. Well, where do we get our truth from? We get it from lots of places. Now notice I put the air quotes around truth. Sometimes our truth comes from investment. I forget who said it, but somebody once said sports is just rooting for somebody based upon their laundry. Right? Right? He's my guy because he's wearing my colors, my team's jersey. I hated him when he was with the other team, but he's my guy now. So fandom is an investment. Truth can come from authority. I use this one multiple times every day. Sometimes as department chair, but always as a parent. Why do we do this? Because I said so. Never works. Works more with department chair and less with the children. The kids are always the why question, like why? Sometimes truth comes from logic, which is what I tried to apply to my mom, showing her that 48 or 44 does not come up more than 28. That seemed very logical to me. Got a whole discipline of philosophers that work on this, try to help us understand. Sometimes our truth comes from faith, and because I like to crap on everything, I found this neat infographic. I like this one. Every line is a contradiction in the Bible, from Genesis to Revelation. So if you can't read it, but all these little ticks down here, we start at Genesis and we end at Revelation. Anytime there's a contradiction, they link the two things, and so you get all of this. It's essentially full, right? There's not a lot of space there. There's not a lot that's in the Bible that isn't contradicted by something else in the Bible. And then finally, science. Right? Sometimes we point to science, but isn't science the thing that gave us this thing? Right? Isn't science the way in which we justify behaviors that we know are bad for us? Like red wine, chocolate. Isn't chocolate really good for you? No. No amount of chocolate is good for your health, professor says. So these are sources of truth for some of us. And it's really hard because it's hard when one truth is in conflict with another truth. And so you have people arguing over, well, what's true? Truth is not truth. I like to collect these headlines that I see because they're coming from academics. Male jurors more likely to find overweight women guilty. So ladies, when you commit a crime and go to jail, lose a lot of weight. The food there stinks anyway and you got nothing else to do. Really work on your body and try to lose some weight. So that way you'd be more likely to be acquitted. Just a little life tip for you. Harvard study. Gun control is counterproductive. Huh? Gun control kills people? What the hell? Because I thought that's the whole point of gun control, was keeping guns out of the hands of people that shouldn't have them. And you're telling me that gun control puts guns in the hands of people that shouldn't have them? Headlines. They're tricky. Finally, this is my favorite one. Friends with benefits have safer sex, study finds. So you're willing to sleep with the person but not be impregnated by them. That's what a friends with benefit is. Like, I will sleep with you, but there's no way in hell we're having a kid. Condoms always. Okay, that one actually does make sense to me. That does not violate any sort of investment I have in how I think the world works. All of these headlines come from studies written by academics who are following social science. Bigger picture out there, there's a whole field of philosophy that just tries to figure out what do we know and do we actually know it. It's called epistemology. Epistemology is the philosophy of trying to separate fact from opinion. And that's where we're going to sort of find ourselves, and that's going to be our goal for our statistics class. Separate fact from opinion. Or another way of thinking about it is, let's test some of our opinions to see if they're facts. Let's see if we can find evidence. In this class, the whole goal is to be empirically based. Empirically, that's a good college word. You should throw that around when you guys go home for Thanksgiving break. Well, empirically, 44 is just as likely as 28 to be drawn in the quick draw. And because I said big fancy college word, you should believe me. I studied epistemology. That'll work. Empirically, if something is empirically proven or empirically believed, it is based upon observed evidence. Okay? Observed evidence. Observation. So the data that we collect and hoard, that is observed evidence. Back to my quick draw example. The frequency in which a number was selected is observed evidence. You can observe that. How could you observe that if you didn't trust the quick draw folks? You sit down, you stare at the screen, and every time a number's drawn, you go 1. Another number's drawn, you keep going. Okay. It's not a hidden process. Right? If somebody says, I can't show you that, then it's not empirically based, because you can't observe how it's created or how it's done. Anybody actually ever accidentally watch on TV how they do the lottery? So they got this machine, and it looks like a popcorn popper, and they put little balls in the machine, and they have an air fan at the bottom, and they make the balls jump because they pressurized the thing with the balls in it. And then they open up a tube at the top, and that allows the pressure to escape, and it takes a ball with it. Science, physics, engineering, just to pick a ball out of a thing. The quick draw is actually just done by computer. It just says, hey, computer, give me a number between 1 and 70. And then it gives you a number. And then you go, hey, computer, give me another number between 1 and 70, but don't replace the one that you just took out. And it does that. That's what quick draw does. How do we reach our conclusions? How do we do science? Well, we follow the scientific method. And again, you've been taught this before. You did this in high school in your science classes. You just did it usually physically in like a chemistry or a physics class, or I don't know really what they do in bio other than like cut up dead animals, but definitely going to go with chemistry here, right? You had a process, and you had to follow the process. You were told, all right, this is the scientific method. Well, the scientific method involves universal processes. So it's open. We know what it is. You are able to do it. Like calculate a statistic. Okay? Miles per gallon. You can calculate that. How do you do that? Well, every Sunday when I go to Costco and I fill up my gas tank, I record 2 things. 1, how many miles have I driven? It's a little trip thing on the odometer. And 2, how much gas did I just put in my tank? right? Because I'm not some poor high school kid that can only put in gas in his tank $10 at a time. Or when I was in high school and I had a broken gas gauge and I did $10 at a time, and then I had to watch how many miles I drove and I'd run out of gas. That sucked. Teenage me sucked. Professional me, haha, fill up the gas tank every time. I can observe those two things. I can observe the change in the odometer, and I can observe how much gas has been pumped into my tank. And then using a very complicated procedure known as a fraction, I can put the number of miles above the number of gallons, and that's miles per gallon. It's not a secret. And you all now have the ability to do that the next time you actually fill up your gas tank. To the top, splashing out, fill it up. This is an open process. I'm going to highlight this, but skeptical. Because anytime you try to invent something or try to make a claim, there's somebody there that's going to be like, really? Are you sure? And this happens all the time in academics. My dissertation, air quotes, proved that public opinion influenced judges when they vote. But my dissertation also said that attitudes or their ideology didn't matter. People didn't like that. Well, how can you find this thing matters when you didn't find that the thing that should matter matter? And I'm just like, science. Open, universal process. Take a look. So there's always a sense of skepticism. That's part of the scientific method. So what do? Built into this is the idea of replication. When you're an academic and you come out and you do a study, that doesn't mean nobody ever does that study ever again. Because if that happened, then we would all be drinking a glass of red wine right now. Because red wine is good for your heart. Like it'd be part of our morning vitamins. Like, all right, kids, wash down your Flintstones with your glass of wine this morning. But we replicate. We continue to investigate repeatedly. Because of this. There's always going to be a healthy skepticism of what is truth. Because let's be honest, does anybody here ever like being told what to do? No, right? We all want to make decisions for ourselves. So whether or not I drink a glass of red wine should be my decision and not my doctor's decision. Because I think he's wrong, because doctors just make stuff up. So there is a little bit of interplay here between skepticism and the scientific method, and that's what you get in epistemology. A bunch of people sitting around and going, well, how do we know what we think we know? And how do we know that? Like if you're ever goofy on cough medicines sometime, try to ask yourself, how do I know blue is blue? Like I see that it's blue, but is it really blue? Or is it just what I see? Maybe the colorblind people aren't blind. Maybe we're the ones that are messed up. Think about that. Actually, don't. You'll never find the answer. I've tried. And then for me, it gets really complicated because I'm a political scientist. I study politics and government. And politics makes things weirder. Because politics, in some respects, people view it as a zero-sum game. And the simplest way to explain zero-sum is that for somebody to win, somebody's got to lose. Okay? Budgets are great examples of zero-sum. I have $10, but I want to do $40 worth of stuff. I want to eat, and I want to drink, and I want to go to a movie, and I want to eat again, and I want to buy some drugs. But I only have $10. In order to go to the movie, I'm going to have to not drink or do drugs or really eat much of anything. Ramen it is. Okay? So in order for one person to win, another person has to lose. And then when you talk about policy and people start thinking about rights, you can identify, well, I can't do this, but that person can. And it gets really weird. And we start arguing over whether or not bakers have to bake a cake for a gay wedding. I hate having this argument. Again, my buddy Duff, he and I have opposite viewpoints on this. I say you're a baker, you bake the cake. And he says, no, they don't want to participate in the wedding. And I said, well, they're not invited. They're just delivering the cake. Like, they're not in the bedroom that night. The baker's not going to get a surprise at the end of the evening. Does not work that way. At least didn't at my wedding. I mean, I didn't fool around with the baker at the end of the night. I was so hungover, I didn't do anything at the end of the night. I just went to bed. I don't even know if my wife was there. Right? But for him, it's about religious liberty and the liberty to bake a straight cake. And I'm thinking, well, I think you should be able to go into a store and not be discriminated against. And there's no answer to this. Because, again, we've set up politics in this idea of zero sum. That in order for people not to be discriminated against, we have to violate somebody else's religious liberty. But if we uphold their religious liberty, then it's okay to discriminate against people. I don't think the cake could have been that good. Again, I didn't even eat my wedding cake. So the problem that we have when we introduce human behavior, whether it's political science or psychology or anthropology or sociology or public health. Do I got any public health people in here? There we go, right? Telling somebody what they should do to stay healthy and not die. It gets a little complicated. We start feeling like we're being judged, or we're being told we're doing things the wrong way. So one of the things that's difficult about statistics is that we have to just recognize that not every problem can be solved with statistics. That there are actually two types of questions out there. We're going to focus on the empirical questions, the questions that involve data, counting, observation. We're going to stay away from the normative questions. Normative questions involve things like should. Should a same-sex couple be discriminated against because of religious liberty? That's a should question. All the data in the world isn't going to answer a should question. It's not, it's just not, because that's not what it's designed to do. Normative questions are about how we choose, how we want things to be, not how they actually are. One of the things you have to do in this class is write a paper. If I get one more person ask me, should women serve in the military, I'm done. So I'm just warning you right now, don't come to me with that question. Because that's a preference. That's a, I would be comfortable with this, or I would be uncomfortable with this. And you might have had personal experience in the military. But again, that's a should question. An empirical question, we're not going to argue over whether or not the answer itself is right or wrong. We're going to argue over the process. Was this measured correctly? What does your sample look like? Did you use the right method? Let's double check your ability to add, subtract, multiply, divide. Because how did you get that number? So we will avoid at all costs normative questions, Because again, statistics is not built to answer those sorts of questions. And how do we do that? Back to middle school science. We stick to a scientific method. Most of this is from your book. You don't have to take like word for word notes. So the first thing that we do in this method is develop a research hypothesis or a research question. The two are slightly different, but I'm just going to plow through that difference. When you were in middle school, you were told that a hypothesis was an educated guess. No. That's just what they told you to get you through 6th grade science without dismembering the frog. What sort of weird stuff did you guys dissect in school? I did the frog, the earthworm, and a kitten. Oh, a fetal pig. I forgot about that one. A squid? Like calamari? Okay. I've not heard that one. Sharks? Wow. What's that? That's really wicked gross. Did you do the sheep eye at Carolina Forest, Cody? Okay. All right. I'm not sure. Again, I have no idea how that changed my life. But it's just like, hey, let the kids look at biology. All right. A research hypothesis, the educated guess. Well, for us, it's an expectation of how we believe behavior works. A statement regarding an expected or predicted relationship between variables. Drinking a glass of wine every day, wine, is good for your heart, your health. That is a statement about a predicted relationship between your heart and your health, your variables. Okay? Now, the name variable tells you what it has to be. A variable is something that we measure that can change. If I'm collecting data and I'm going to do a survey of every person in the room, I should not ask you what planet you live on. Why? You say that, but you haven't met the people I've met. Why shouldn't I ask you a question about the planet you live on? Because the answer does not vary. Everybody's going to say the same thing, or at least better say the same thing. Earth. Right? Just double checking. Make sure everybody knows you're living on the planet Earth right now. Okay. It does not take on different values. If nothing varies, you can't test the relationship. We can pretty much measure anything. One of the most obnoxious things I've ever said in my life was that I have a PhD from a Big Ten school. I can measure anything. And it's true. I can. And that was really obnoxious. But I can. I can measure anything. Shout out something, I'll tell you how I measure it. With a tape measure. So you can measure the Statue of Liberty. I can measure what it's made out of, copper. I can measure its height. I can measure its color on the Pantone scale. I can measure its age. We can do carbon dating if we wanted to. You can measure anything. I can quantify it too. Test anxiety. Ask you a question between 1 and 10. How much are you dreading taking this test tomorrow? Oh, I'm a 10. And then for 10, I can say, okay, are you vomiting? Do you have sleeplessness? Are your hands trembling? Is your heart racing? Right? I can come up with symptoms, or I can come up with a category and say, how well do you fit this description? Test anxiety 0. How do I measure that as 0? They go, what test? 0. They have 0 test anxiety because they are unaware that the test even exists. Exposure to violence. How many people has my 5-year-old son seen killed on TV? A lot. And do droids count? They're kind of cute and they say things. Roger, roger. But they're not actually people. So is it okay? And where do we go on the whole alien thing? Because are aliens really people? I don't know. Parenting styles, amount of exercise, right? All the things that we focus on and how we should live our life, well, we focus on them because they're changeable, they vary, and they can be quantified. And I can measure them. I can measure the amount of calories you burn in a day. Well, wear these medical fitness trackers now, right? Measure the number of steps you take. 58 steps from the first floor to the third floor of Britain. 56 if you take the other stairway, which is why I used to take that one. But it has to vary. It has to be a condition in which we can see differences, because we're trying to use the differences to explain the difference in the outcome. Right? Where do we get our research hypotheses from? I don't care. You can get them from anywhere. You could be reading a book and be like, I disagree with this line in the book. That's how a friend of mine got his dissertation topic, which is something graduate students usually struggle with. And I'm talking to him like, Scott, how did you decide to write your dissertation? He's like, well, I was reading this book and I saw a sentence and I'm like, no, that's wrong. I'm like, oh, so all I need to do is keep reading more and try to find something I disagree with. Okay. That's known as a literature review. And hopefully, at some point during your time here at Coastal, you'll be taught what a literature review is. It's not an annotated bibliography. The English department's lying to you. A literature review is when, usually in writing, so most papers have a section called literature review, you try to explain what we know about a topic and find an unanswered question. Or explain what we know about a topic and point out how it's contradictory. Research hypotheses can be very simple questions. Is there a blank in blank? Is there a gap, a gender gap, in party ID? Are women more likely to be Democrats? Are women more likely to support insert policy here, whether it's abortion, the death penalty, etc.? As you get older, do you get more conservative? Because I'm pretty sure that's what Fox News is banking on. If you ever watch like the commercials, it's a lot of death going on in the commercials at Fox News. Investing in gold and reverse mortgages and Medicare supplements. Like, a lot of death about to happen on Fox News. Okay. What is the effect of a change? What is the outcome due to a policy? A difference. Okay? Remember, both of the blanks have to do what? They have to vary. So our research question and our hypothesis is really the statement of the relationship, or trying to answer a question about the relationship between two variables. Mr. Little, do you have a other partner, significant other? You looking? Okay. So let's say Mr. Little here is spotted with another person frequently. And we'll go, wonder what's up with him. I wonder if he's with that person. Research questions pose a question about the relationship between two variables. I wonder if those two are together. That's a research question. A hypothesis suggests an answer to those questions. Those two are together. Slight difference, right? One is the broader topic. I wonder if these two are together. They're around each other a lot. A hypothesis is those two are together. Let me tell you why. What evidence I have, they sit next to each other in every class they're in. Yeah, they're together. Actually, that's all I need. I'm done. The independent variable. The variable manipulated by the researcher. I don't like the book's definition of that. Because in this example, did I manipulate these two? No. I just observed them. They're together. What am I using? Proximity. So the fact that he's here and they're there versus he's here and they're here. Distance between them. I don't always, as a scientist, have the ability to manipulate. But what I do have the ability to do is observe. Is anybody here from, let's start with the West Coast. Anybody here grow up on the other ocean? Or approximate to the other ocean? Anybody here from Canada? Anybody here from want to say they're from Canada? Thank you. Okay. Your name? Kate. Kate's from Canada. Can I make Kate be from Canada? No, it happened before we met. Right. It is not like a light switch, which I wish I had a real light switch instead of this thing. Because that happens. Because that happens. Turn off, damn it. There we go. Whew. This is manipulation. You're all Canadians. You're all Americans. There's no button or switch that I can push to change that. In some studies, the researcher can manipulate a variable. Like in a medical study. How do they decide in a medical study how to manipulate the independent variable? Let's say we're testing a new drug. What are the ways in which I can manipulate your intake of a drug? There's two answers, so you're not automatically going to be wrong. Okay, how much of the drug do we give you? Right? At what point do we actually harm you by giving you more of the drug? Do you know that vitamin A can actually harm you? Does anybody know that? You know what happens if you take up too much vitamin A? First, you get a massive growth on your spinal column, and then you die. because vitamin A is a fat-soluble vitamin, not a water-soluble vitamin like vitamin C, which when you're really hungover, you think vitamin C is like the cure. You're just going to pee it all away because it's a water-soluble vitamin. So even something as innocuous as a vitamin, if in too much quantities, can harm you. What's the other thing I can do in a medical study to decide to manipulate the drug that I give you? I can just not give you the drug, but I can give you something that looks like a drug so you think you're taking a drug. That's called the placebo effect. The dependent variable is the outcome that we're trying to observe. So in a medical study, do you die or not? They're known as survival models. There's a whole branch of statistics designed to predict how long it will take you to die. Survival models. And when you don't want to make it about death, we call it a hazard model. Like you might die. Or an event will happen. So we measure the outcome. So at some point, I'm going to have to know. Are you two together? Let's see. I was right. I'm going to have to measure the outcome. How do I do that? Well, I have to collect data. This is where the observing part of empirical study comes in. Most frequently, what we end up doing is drawing a sample from a larger population. Why? Because populations are big, and collecting data on everything can be expensive and time-consuming, or just plain old impossible. A population is the total number of possible units, elements, cases that can be included in a study. So any study that's ever done that doesn't involve you does not have a population, it has a sample. Because you exist. You are here. Any public opinion poll that's ever done, any medical trial of a cancer drug, television ratings. Nobody asked you what you watched last night. So how could they know if you watched whatever was on last night? What they've done is they've taken a sample. A sample is a subset. It's a small representation. There's a little bit of epistemology behind trying to say what is a sample and what is a population. Some of it is a matter of perspective, and there are actually ways in which you can say that you have a population, as long as that population is pretty small. Okay? So if the population is college students, well, the sample can be you all. You all are my sample. You are a college student, yes? I hope so. Hope you're paying the university to sit here and listen to me. Everybody here a college student? Okay. You're a sample, but I can't use that as a variable, can I? Because you're all college students. Okay. Our population could be registered voters. So that's something you have to sort of do, right? You have to join and register yourself. You make the choice of whether or not you're in the population or not. So you can draw a population from a sample. What are registered voters a sample of? Give me the population that they fit into. Think about it for a second. What do you have to be in order to be a registered voter? There's another thing you have to be. Okay? So the population is citizens over 18. The sample is registered voters. Population, people with an affliction. People with depression. People who are overweight. People with heart conditions. People with color blindness. That is a population. It's also a sample of humanity. Or, again, you can have a smaller sample, people who have been diagnosed with it and are getting a particular form of treatment. The population sample split is just not two groups. They sort of extend outward. You can have a sample within a sample within a sample, and next thing I know, it's Inception, and I'm not sure if Leo's in the dream or if he's out of it or not. Which is probably too old of a movie reference for you guys. So you have a question, you have some data. The next step is to select a method. How am I going to answer this question? Actually, you might want to think about this before you collect your data, because it tells you what the shape of your data should be. So this is another thing that bothered me in thinking about the ways that you're taught the scientific method versus reality. You're taught that it's the sequence of steps, right? That you come up with your hypothesis before you collect your data and do your test. Yeah, real world doesn't work that way. We do all these things at the same time. It probably means we're doing it wrong, air quotes, but that's the reality of how it's done. So when you sit down to write a paper, if you're like me, you might not necessarily write the paper sequentially. You might not start with the introduction and then do page 2 and 3 and 4 and then finish with page 5 and then do your works cited and you're done. That's not how I write papers. I think about this, I write a little bit here, and then I do this, and then I cut and paste and maybe wiggle things around a little bit. And I don't like this here, I'll move it up there. Same thing with the scientific method. You might select your method before you even figure out what your question is. Why? Because it's the only thing you know how to do. There's this expression, when your only tool is a hammer, every problem is a nail. Just go ahead and I have my hammer. Anytime I need to do something with my hammer, I just hit it with a hammer. Because that's the only tool you have. So you need to screw a screw in the wall to hang up a picture. You need a screwdriver, but you have a hammer. Guess what? You've turned that screw into a nail. Or pen, or whatever else you want to hit with it. For us, our method, because we're going to learn statistics, are going to be the methods we learn in the class, which are tests for causality, which may include other variables or other explanations. That's actually the next class. I take you right up to the part where you can put in other variables. And again, this is all in the book, and I don't really want you to be slide copiers. So I'm really going to do something like this, and you're going to go, ah. But again, thank you. You don't have to copy down the slide. I just want to talk about it for a second. Talk about write down what I'm talking about. So we have experimental research methods. Again, the classic scientific method that you're taught in high school. But again, I can't do the switch thing and turn some of you into Canadians. I can't make some of you gay. I can't make some of you know somebody that's been murdered. My favorite all-time survey questions. Do you know anybody that's been murdered? Can't do that. So instead, I have to sort of look at non-experimental research methods. So a quasi-experimental research is when you look for conditions that already are different. compare your classes where the professor uses the projector versus classes where the professor doesn't. Anybody got anybody that never uses any of this? They just stand up and talk? SIBO. Okay. SIBO comes in and he talks. Okay. That's one method. We can compare the learning that occurs in SIBO's class, no comments, versus the learning that occurs in this wonderful environment with a board and a tablet and putting stuff on Moodle all the time and recording my lectures, right? So we got like nothing versus overkill. We can compare whether or not you learn in those two things. Did we knowingly change those conditions? No. We observed the difference in the conditions. Survey research is non-experimental. Survey research is just collect as much information as you can. And then when you have the question, see if you have a survey question about it. That's really what they do. They're like, let's just ask as many different questions as possible. And at a certain point, like people either hang up the phone or they won't answer the 88th question. So if you ever take a survey online, notice they lie to you and they say this will only take 5 minutes. Well, it really takes 10. But you've invested at least 5 minutes into it, so they'll finish you for the last 5. Observational research. What if you can't communicate with your subject? You can't ask them a question because the ocean doesn't talk back to you, or the chimpanzees, or the rocks that you're studying. That's known as observational research. Especially useful when you cannot ethically manipulate an experimenter. So I can't ethically do something to you. Like kill one of your friends. So that way I can get the answer to the, do you know somebody that's been murdered question. Can't ethically do that. Or our friend archival research, where you go and try to find data that was collected but they didn't even know it was data. Like postal routes from the 1880s. Whether or not mail delivery was available in an area. And does that help a group form or not? Right? Okay. If you walk, if you're on the 3rd floor, the comm department has an information board, and they put up posters from previous conferences, and there's one like songs about touching yourself, or touching, or your body. I'm like, oh, okay. That's actually archival research. You go back and you code for the content. Or the research that I do on campaign advertising. Go back and look at the ads. I'm not collecting it myself. I'm going back and finding something that's already been collected. This is where social science lies. And finding to take what we have and make it look more like an experimental framework. There are some disciplines. So psychology. Anybody here take an intro psych class where they make you do the experiments that somebody else is running? I had to do that when I was an undergrad. I had to complete 10 experiment hours. Down in the basement, which was all dark and creepy, they had the sign-up board, and you agreed to go. And sometimes they gave you information about it, like you'd be playing a computer game. Or sometimes they didn't, like bring a towel. And you'd show up, and they would try not to harm you. Tell you you're playing a game for money, but there's no money because you're not playing against anybody. You're playing against a computer, and you can never win. A little mad about that one. Social scientists, we're really not doing this. I will say public health, you got a little bit, right? Maybe in political science, if we educate somebody and then see if that changes their attitudes. In public health, they have these exercise campaigns and see if that has an effect. That's somewhat experimental. But for the most part, what we need to do is we need to recognize that we just need to use somebody else's data. And that's where this class comes in, right? You get data, you analyze it. In this class, we're going to learn about 2 different types of analysis. The first half of the class is known as descriptive statistics. These are the ones you learned in middle school. Measures of central tendency like the mean, the median, the mode, and measures of variance, standard deviation, the range. You've learned these before. My daughter's done some of these in 2nd grade last year. But where we need to get to is what we call inferential statistics. That's where we use statistics to test our hypotheses and reach a conclusion. So is there a gender gap in regards to support for the death penalty? I need to get some data that asks different people, both men and women, about their support for the death penalty. And then I'm going to compare the support rates for those two groups, men and women, and not only see if they're different, but if that difference is really big and expected from a sample drawn from a population. This last part, being able to generalize from our sample, is where we bring in probability theory, and this is where people struggle. Because I got to do a curve, and there's a chart, and this is where it gets really hard. Because you stop doing math, and now you're into procedures. Okay? I think I'm out of time. Am I out of time? 10:15, 12:05. I'm out of time. I'll finish up the last 2 slides next class. For next class, so the other half of the week, there's a video about literature review. I walk you through a couple of websites that are going to be helpful for you. I also show you a citation management program that'll change your lives if you actually use it. So go ahead and watch the video. That's part of week 1.